discuss about hash table today. Okay, so first of all, what is hash table in C sharp? Basically, if you see the definition of hash table, it says like a hash table is a collection of key value pairs that are arranged based on the hash code of the key. So basically, we have the function method actually which will be generating the hash code, and based on that, the records will be inserted in the hash table. Or in other words, a hash table is used to create a collection which uses a hash table for storage. It generally optimized the lookup by calculating the hash code of the every key and store into another basket automatically. And when you accessing the value from a hash table at that time, it matches the hash code with the specified key. That is, first of all, when we will try to retrieve the data, the hash code of that key will be find out, and based on that, we will be retrieving the particular record values. So it is a non-generic type of collection which is defined in this namespace. So this is what that you saw, this definition is for the one that we have a built-in hash table and we can make use of that. Okay, here currently we understand what exactly hash table is, where basically the records will be inserted based on the hash code. And how hash code will be generated? Has to calculate the hash code, we have a method called hash code itself that will be generating the hash code corresponding to every key, and then accordingly the records will be inserted in the hash table. So in this video, what we are going to do, rather than using the inbuilt hash table that is available in this namespace, we will be creating our own hash table, and we will see like how basically records can get inserted into that, how basically we are supposed to write the logic. Also, while implementing the hash table, we will also keep in mind about these features like in hash table the key cannot be null but value can be. Okay, we will see whether we are implementing this or not. In hash table, key object must be immutable, something which cannot be changed once it's created. Okay, as long as they are used as key in the hash table. The capacity of a hash table is the number of elements that hash table can hold. A hash function is provided by each key object in the hash table. The one thing as of now we will not paying attention about this one, the one means the hash table that we have provided as inbuilt will be implementing this much interfaces. Okay, but we will just to simplify the things, as of now we will not be implementing this much interfaces. Okay, we will just be creating a very basic and simple hash table which resembles like the one that is available as inbuilt in C sharp. A hash table, you can store elements of the same time and of type different type as well, which is basically applicable to any collections, right? The element of hash table that is a key value pair are stored in dictionary entry. So you can also cast the key value pair to dictionary entry in hash table. Key must be unique. Duplicate keys are not allowed. So what is a hash table we saw here, and what are the things that are associated with hash table is here. We have all the requirement. Based on that, we are going to create our own hash table. Okay, so we already have written this one, I have this code available, so I will explain you and will make sure whether these things are we are implementing in our hash table or not. Okay, so here we will trace the code, and along with that, if possible, I will also try to explain you with the help of diagram also, so it would be easy. As of now, we have created my map node, and this class will behave like a hash table itself. Okay, so inside that, we are trying to store as of now three records only, just for to reduce the complexity and make the things easier. I have taken only three, and we will be tracing the code. We will see how we are, whether we are implementing the things or not, as well as we will also check like how records are getting inserted and how we will be fetching the record. So this is what basically we will be doing. So I will execute this code in debug mode. So if you see, simply I will execute, and now what will happen, control came here. If you basically the object of my map node will be created, and since this class is implemented generics at class level, if you see here, it is implementing generic key and value pair, right? K stand for key and V is a placeholder. Basically both of them are placeholder where we are supposed to pass two type, and that's why we are passing from here first one as a string and second also as a string. That is, afterwards wherever key will be there, I mean k will be there, each key will k will start behaving like a string type, and same for v also. V will also start behaving like a string type, because if at both of these placeholder we are passing a string. That's it. And then in the constructor of my map node class we are passing as 3. So I will press F11 to check what will happen on the execution of that one constructor. So inside this, this size has the value 3, and this dot size is getting initialized with the value this 3. That is, this size will have value 3. Okay, so after initialization in the constructor, what we are doing, the global size variable that we have will have value 3. This dot size represent to global variable of the current class, and this is the local variable that we have created inside input parameter. Also along with that, we have one global array of type linked list. Okay, and that is getting initialized here, and in their size we are passing the size of 3. So one array will be created inside my map not object, and they will have their size 3. So if I draw the diagram, something like this will happen in memory. Like if I can see, so I will say one object will be created. Just assume this is an object. Okay, and on this object we have two variables, size as well as item. So inside this, in my map node, definitely some address will be there. So that address can be treated as 1000. Maybe we are taking any just a random values. Basically this is done by the operating system, they will allow any address. So 1000 become the address. Just for the sake of simplicity, let's put their name also as a. So this is what basically object got created, and inside that we have two variables, size as well as items, and both are initialized. So size will have a value 3, and this item basically is an array of type linked list which will be currently empty. Okay, none of the values we are inserting, but definitely one empty array of size 3 will be created. So here we will have basically size value set to 3, and array is again like a reference type, so it will basically having the some address, so item. And here what will be the value? So actually value will be the it will be holding the address of array. So again somewhere in array, I mean in heap, this array will be created with size 3. So I will see draw diagram like this, 1 2 3, and they will have their index like address. Let's take their address. So I will say assume this has a 2000 address, and the name of the array can we see like b array. Okay, this is I'm taking just for simplicity, and then respectively they will have their index also. So this will be treated as a 0 index, this will be 1 index. As we know, always index starts with 0 in programming languages, right? And then this is 2. Okay, so these are indexes. Now basically this item will be holding the address of this array, that is nothing but 2000. Okay, if I try drawing the diagram, so here item will start pointing to this object called array. To be more precise, this is the array. Okay, so item will be pointing to this array, and since this array is non-primitive data type, means we told this array will be only of type linked list. Means linked list is what? Non-primitive data type. So by default all of this section will have null as a default value. So they also will have null, and here also it will be null only. So this is what basically will be happening when this will execute. Okay, that's it. And then you see basically when object gets created, along with creating the object, their address will be assigned to the hash, this reference variable. Okay, so I will say somewhere here one reference variable may be created like this, and it will be holding the address of a object has. Okay, so like I can say like this is what basically happening on this execution. Now our my map not object got created. This is, as I told you, we have to make this my map not behave like hash table. Okay, so now we will see how basically we will be inserting the record in the my map node as we are ready with our setup. Okay, so we are trying to insert 0 with value welcome. Let's see how it will work. So I will press F11 here in the add method. Key is of type string. You know very well. The reason is during the time of creating object, we pass a string and a string. So this string will be taking the place of k placeholder, and this string will be taking the place of v placeholder. Okay, so wherever you see the k will start behaving like a string, and v will also start behaving like a string. So key is currently 0 and value is welcome. Let's see how these records get inserted in our hash table, that is nothing but my map not object. Okay, so here we have one method called get array position with value key 0. Okay, we will see what exactly this method is doing. Since this method is present inside the same class, that's why we don't need class or an object. Directly you can call like this. Okay, as you see basically here get array position is present in the same class. Okay, that's why we are able to call like this. I want to see the definition of get array position as well. So I will say F11, and here with key you see 0 of a string type basically is here. And now we are trying to find hash code as I told you during the time of definition. Like key here in hash table is a collection of key value pair that are arranged based on hash code of the key. Now we will see what was the meaning of this line here. They will be arranged based on hash code. So first of all you need to find out the hash code of the key, and then only we will be able to insert the record in our hash table, right? So this is what basically, that's why we are trying to find out hash code. If you remember I told you we have a hash code method. This method will be helping you to get the hash code of that particular key. So currently in place of key we have 0 as a string object, and on that we are calling get hash code. So this method will be giving some hash code value. If I say F11, you can see this is the hash code, and hash code looks like this. Okay, this is a numeric value that gets generated. Okay, so this hash code was generated for the key 0. Okay, and now this is 1717782, something like that. Now I will say let's go to next line. Here what we are doing, the on hash code we are trying to find the modulus, which will nothing but it will return you the reminder. Okay, so hash code is 177 something like this, modulus size, and size is 3. So what it will do, this hash code will be divided by 3, and whatever will be the reminder that will be given as the value, because modulus operator, which this operator will be returning the reminder. Okay, so if I press F11, you can see position became 3. How? Basically this number will be divided, and after dividing this number, whatever the reminder will be left, that is returning from here. Okay, so it returned 2. Now we are calling one more method called abs. Basically this is like absolute method, which will ensure if a number is negative, this method will make it positive. If the number is already positive, it will make it remain it as it is. Okay, because the purpose of writing this line is sometime hash code may return negative values also. Since it returns negative value, the reminder will also be the negative. Okay, and then since we want this number, whatever the number that will be returned at that index, we want to insert the record. But if it will be the negative number, you know very well that it is not possible to have negative index in array. Just for that reason, we are calling abs method, which is nothing but x, like it will return absolute value, that is positive value. So currently we already have the positive value, so as of now it will return as it is, that is nothing but 2. Okay, so here position is 2. If I say if you want to cross check, you can make it -2 here itself. Okay, here enter, and now intentionally I made it. Now if I execute, so you will see, even though I made the number negative, it is returning positive. Okay, so this is what the functionality of abs method is. Okay, if I'm talking about still this method, right? Like if you will give it input parameter as negative, that number it will make at positive. If the number is already positive, it will return the positive only. So this is what. Now this position we received is 2 basically. Okay, so now what we are going to do, we are checking at that position. We have another method called get linked list. Okay, and in this method we are passing the same position. You can say this is index. Okay, so if we go here, in that one position is set to 2, and then what we are doing, we are checking in the items array at that position, at that index, whether values are there or not. So if you see in our diagram, in item array, that is nothing but B array, at index 2 value we have null. So same null will be returned into this local variable called linked list. Okay, and in this basically value will be null. Now, since this value was null, so here linked list double equal to null. Yes, of course, condition will be true. Control will go inside this method if block, and here one more object of linked list with key value data as a generics will be created, right? And k and v will still remain to their default value, that is nothing but a string that will be passed. So one object will be created, and at that, basically let's draw one linked list object. So here assume this is one linked list object. Okay, and let's take some address, because whenever object gets created, definitely they will have some address, and name we are giving for our convenience purpose, nothing else. Okay, so c is the object, and when this object will get created, definitely they will have other properties like first, last, current, count and all. So as of now, let's leave it as it is and just believe this is a linked list property, where it might also have a header which will currently set to null. Okay, as you know, a linked list have the header property which always will be pointing to null. Since this header is going to be helpful, so as of now we will say this header, or you can take any variable. So we are just assuming the header is there, and currently that will also be null if there is no element inserted in the linked list. By default, header will be null only. Okay, so this is what basically it will set to null. Object got created, and their address will store inside this linked list variable, which is nothing but this that we created. So one linked list reference variable will be created, and linked list is equal to, they will have the address of c object. Okay, that is, this linked list will start pointing to c object. Okay, then in the next line, what we are saying, whatever the address that we have in the linked list, that is nothing but, if you see, that is 3000. Okay, so whatever the address we have inside, that same address we want to store in items at position. So at position, what, at 2 means second index. Position is like index here, so you can say position or you can say index, both are same in this example. Okay, so item at index 2, we want to store the address that is present in a linked list. So that is nothing but 3000 at index 2. So here at index 2, it will be holding the address of C object. Okay, so here it will be holding 3000. And if I try drawing the diagram, so this will, second index will start pointing to this object called C object. Okay, so that's it. and then returning the linked list means this linked list will whatever the address they are holding, that value will be returning. That is it, this method is returning the address of C object, because currently this linked list is holding the address of 3000 only. And we know when method completes their execution, all the local variable gets wiped out. So linked list is the only variable that we created locally. So after returning the value, that object, that reference variable will be deleted. So simply, this array will be removed. Okay, along with this variable, and 3000 that was stored, that will be returned. Okay, so it will return the address of and then that again this linked list is another local variable present inside this. So whatever was returned from this method linked list, that variable now will be storing the value in this linked list, which is another. Okay, so this linked list again will start pointing to this C object. Okay, because it will also start pointing to C object only, as they will receive 3000 as address. So this linked list present inside this. Okay, I want to clarify one thing, guys. The linked list present inside this add method is different, and the linked list variable that we had present in this method was different. As you know, they are local variable and they have the scope within this method only. So as soon as this method will execute this complete their execution, immediately local variables will be wiped out from the stack, and this linked list basically is still there in a stack because add method is still executing. That's why. And again this linked list variable is different, and currently since this linked list also receive the address of a C object only, that's why one linked list object, that this reference variable will also start pointing to C object. So again I will draw like this, equal to 3000, and this linked list variable is because of add method, because we have defined this variable inside add method also. If I draw the arrow, so this linked list again will start pointing to C object only. And after that, here what we are doing, we are instantiating the key value data, which is nothing but is our structure. Okay, if I show you the structure here, struct, so we have key value data. Inside that we have taken key and value. As you know, struct is nothing but its value type. Okay, so just to simplify the things, we have taken it as a struct type. Okay, and inside that we have key and value. So here we are instantiating and we are passing the value of key and value. That is, key is a property and that has a value of 0. Value, this value is a property and will be holding the value of this value, which is nothing but welcome. So one object, you can say this basically struct will be instantiating, and inside that there will be two property, key and value, with key as 0 and value as welcome. If I draw, so somewhere again one object will be created. Okay, and inside that key will be 0 and value will be welcome. Something like this will happen. And let's suppose they also have some address, maybe you know 30 3500, any address you can take. And then if we want to give their name, we can give that also D. And this one will be pointed by this item reference variable. Again, don't get confused with this item, item that we have inside the A object and the item that we are creating currently inside add method, as this item is local variable to this add item. And since this is the local variable, so they will have their life cycle as long as this method only is getting executed. Once it will complete their execution, this item will be removed. Okay, so this is currently the instantiation of this struct happened, and there this item will act as a reference to this struct object. Okay, so here one more item I can say will be created, and they will be pointing to D object. Okay, they will hold their address. So something like this, if I draw the diagram. will be happening. Okay, on the next line, what we are doing, the link list dot add last. Question is which link list? The one that we created here locally. If you see, this link list still is pointing to C object. Okay, and so in that C object, in last we want to add the address of item. I told you we took just header, so this header has null. Now it will be holding the address of D object. Okay, so this I'm just taking to simplify the things, guys. As one node will be creating, inside that there will be address as well as data, but here assume this header will be pointing to this D object because of this line, because add last method will add this item to this link list. So here this header will have the address of D object, or you can say struct instantiation. So they will have some address and that will be stored here 3500. So if I draw, so header will start pointing to this. Okay, so this is what basically will happen, and at this point of time things will looks like complex, but you know everything will be erased. Just wait, and once it is done, so here this method is going to complete their execution. Now if I tell what exactly will happen, so here all the locally created variable will again be wiped out. So here position, we didn't consider this in our diagram, but you know that will also be removed from a stack. Link list and item, these two also will have to remove. So as of now I will erase, so this item will be removed because add method completed their execution, as well as this link list also, because this one was also created within that. So this is how basically records are getting inserted. Okay, so this is how it is acting like. Okay, and now we have one record inserted of D object inside our hash table. Definitely mechanism are little lengthy, but this mechanism basically is we are implementing in order to make a hash table. This time we are creating our own hash table. We are not using the one that is provided by Microsoft. Okay, so we successfully added. Likewise, same mechanism go for another key 1 and 2. So let's execute again. It will find out with get array position here. At that, it will find the hash code of 1. So hash code of 1 got generated here. And as I told you, sometime get hash code method return negative number also. Okay, and that was the reason that we called app. So here, if you see, we are getting negative number. Okay, and after finding the reminder with 3, definitely we will get again sub negative number only, that is -2, right? So -2, and this time math dot apps. Okay, so this one will make this -2 as +2. Okay, so here if I show you, so you see basically position became 2, and this conversion happened because of ABS method, absolute method. Now position is 2. Okay, and we will say ki get link list position. Okay, if you remember, in our array we already have something inserted at second index, and again we are getting 2, right? Same index. So let's see what happened this time. Okay, so position became 2. We will go, and now inside this we will check whether in this item is there anything already available at position 2 or index 2. Yes, already we have. So this time this linked list will not be null, because if you see in our item array at second index we have the C object address, right? And definitely this is not equal to null. So this time this linked list will not be null. In fact, you see count is 1, means whatever the linked list that is at second index, in that linked list one element is also inserted, that is nothing but D object. Okay, so this is what. And then if linked list is equal to null, no, this time it is not null. So if it is not null, you just observe what is happening here. So it is saying return linked list, means whatever the address we have, return the same, that is address of the linked list. Which address, guys? Here देखो, here item at index 2. So item in items at index 2. Okay, so we can make this spelling as here. This is items. Okay, not suppose this is items. Okay, so items at index 2 we have 3000. So same 3000 will be inside here, and that only is getting returned from here also, means 3000 as the address, or you can say in our example address of C object is getting returned, right? So this one will execute, and now in this linked list, it will be also the holding the address of C object only. Okay, will be pointing to C object only. If I draw the diagram, again I need to create one linked list variable, and they will be holding to C object. And again, this linked list is created from B object. Okay, sorry, not B, but from add method. Okay, this is a local variable, so this is what will happen. Again we are instantiating the extract, okay, with key and value. This time we have our key as 1 and value as 2. Okay, so let's see what will happen. It will instantiated. I will say one object will get created. We can say here E. Let's make their address maybe 4000, and inside that we will have the key as a string object of 1, and then value as 2. Correct. So this is what will happen. And then, in this linked list as D already present inside that. So here what will happen, ki linked list dot add last means ki now in this linked list there will be, what I can do, just assume ki this is a node. Okay, if I draw the diagram here, so this is a node and will be pointing to the first object. Inside that, now this second one is the data part. As you know, this I am drawing just to explain you. So in node, first part is holding the data, second part will be holding the address of the next object. So maybe here, assume any variable you will have some, as of now I will say next. Okay, this you can find, since this is the object of here is the object of linked list, and inside that these are like node. So I'm taking one arbitrary variable next, and this actually will be holding the address of 4000. Okay, why? This one will start pointing to E object. Why this one? This one will happen because of this add last method. That is ki whatever the item got created, means item is nothing but this E object. Okay, I can say here item as the variable with the 4000, and this item will be pointing to this object. And then we are saying ki in our link list, and add last means go and add the this item address in last. So item is holding the address of E object, that is 4000. So this next will be holding the address of 4000. Okay, this is how it will be inserted. So in our C basically is a linked list. So first element is D object, and second element will be E object. Okay, if I draw, so again you can say that this is a node where this one will, okay, it is getting little lengthy here. Okay, and first part is the data, and second part you can consider will be of type next. So this next you can assume as null as of now. Okay, so this is how basically will be added. And after that, again this method is completed their execution. So all local variable will be removed. Okay, in fact key and value, these are also treated as local variable only. So key, value, position, linked list, item, all of them will be removed. We have not draw the diagram for key, value, and this one. So leave it as it is. Link list and item, we need to erase it out. So this is the link list that will be removed. Okay, and then another one was item, right? So this item will also be removed because this item's address is already present there in this next. Okay, so as of now, this is how the record will be added. Okay, then at next we added successfully, then 2. So again this 2, and also guys, you need to find out कि you saw 0 inserted, 1 inserted, and how were they inserted. Basically, in order to insert, first of all, a hash code were find out. Since 0 and 1, both of them had the same hash code, right? And I mean, even though they were having the different hash code, but after finding the modulus, we were getting the same index, that was 2. And at that index earlier already welcome value was there. So in order to insert it, we are just adding in that linked list, not here in this array. And by doing this, we are ensuring that in hash table, key must be unique, duplicate keys are not allowed. At this point of time, you will ask, "Ki we don't have duplicate key, we have 0 and we have 1." But what happened? Because of the finding the modulus, we got to know, since their remainder became same. And if you think from that context, we are assuming they are having the same index. If they will have, as long as they will have the different index, by that time they will be separately inserted in this array only. Okay, but as long as based on their hash code, you will say, why are we finding the hash code then? Because this is the main principle of hash code, that in order to ensure, in order to arrange the data, we must need to find out the hash code of the key. And so we are doing. Okay, after that, where exactly it needs to be inserted, so we are finding that by finding the modulus of, what value, the size of this array, so that we can get the index for this array only. So currently, for 0 as well as for 1, we were getting different hash code. But after finding the modulus, after dividing with 3 in our example, we were getting the same position, and at that position already someone was occupied, that was welcome. So we are adding in that linked list, okay, but not in that array. This is how we are doing. Let's go quickly for the value 2. So here this time again we have the key as 2 and value as hash table. So here, with the key we are trying to find out the hash code. Let's see whether what is the hash code. So again it is negative, that will be taken care by abs method. And let's find what value are we getting after finding the size, that is 1. Okay, minus 1, so it will be 1 this time. Then get linked list method actually does nothing. What it does, it checks whether records are there at that position. Okay, if I show you here, this is the method, right? Here it check whether records are there at that position. So at items, at index 1, so you can see at index nothing is there at 1 except null. So it will be returning as it is, that is, wait, here it will return the null. Better I will say F11 and control came here, it will search. So at this one index, position is 1 means index is 1, so at one value became null. Okay, so in this linked list variable which will be created locally will have the value null. Linked list is equal to null. If it is null means we are good to record the insert, to create one linked list object, and that will store their address will store in this array. So here it is null this time, because at position, at index 1 nothing is there. So this null will be assigned into this variable. Since this linked list become null, so null is equal to null, condition became true, it came inside this one. Another linked list object will be created of inside which we will be able to store key value data type, right? This is generics at linked list. So one another linked list will be created. This is a, I will say here or somewhere like this. Okay, and again like previous C object, they will also have one header kind of thing which will be pointing to first element. As of now it is empty, so they will be null. They will have some address, maybe 5000. Let's take their name as A B C D E, and we can say this is F object. Okay, and their address basically will be stored inside this linked list, means this. Okay, so here we have one linked list reference variable, and they will be holding 5000. It will be pointing to F object. Okay, and then items position means whatever the address we have, that address we want to store in items array at position or at index 1. So currently this linked list has value 5000, and same 5000 we have to store at items array at which index, at first index. So simply erase this out, null will not be there. Now null value will be overridden with 5000, and this one will also start pointing to f object, this one. Okay, so it is pointing to this now, and then returning the link list. Okay, so see, when this line will execute, after that, it is returning the address, which address, 5000. Okay, and after returning, the link list from this method will be removed. Okay, means officially I should remove it, but I will not, because again I have to create the link list of variable that is present in here in add method, right? This one. So you assume this variable earlier was erased, and now this linked list is available for add method. Okay, so this will also receive the same address, so same diagram is valid here also, 5000. Okay, because for this method will be returning the 5000, and this one will be stored inside this linked list. Okay, so we'll created. Now we are again created the object of key value data with key as 2 and value as a hash table. So somewhere you can create, maybe here, inside that you can say this one will be 6000. Then we can say this is the G object. Here we will have the key as what? Key will be 2 and value will be, you can see we are ensuring that hash table value was, so value is hash table, right? So hash table, this is hash table. Okay, so this is what basically will be there, and then their address will stored in this item local variable. So one item will be created with value 6000, and officially this item will start pointing to G object. Okay, that's it. And then this item address will be inserted into this linked list. Which linked list? This, the linked list currently have pointing to F object. So now their header will start pointing to G object. Okay, that is, I can erase this out, and in header basically they will be holding the address of, you can assume like 6000. So officially inside this linked list also one element got added, and it is no longer blank. Okay, so that's it. After that this method completed their execution. Other part you already know, item and this two variable, in fact these will also be deleted, but I have not considered. So linked list and item will be deleted as of now. I will erase just to simplify the diagram. Okay, an item, here is the item. Okay, so this got deleted. Okay, and we successfully inserted this many record. Okay, now what we are here, note this is the fifth index, I will say the 0th index, right? 0th index value, and here in we are storing inside this file, leave it, not an issue. So whatever we will be finding at 0th, we are passing this as a key. So let's see how basically values we will be able to fetch. Okay, so we'll go, and now we will see the get implementation. So key is nothing but 0. Then we are saying get array position. Do you remember, in order to fetch the record, it says first of all we will be able to find, right? So here in hash table the key cannot be null, we will see this. In hash table key object must be immutable, as they are used as a key in the hash table. Capacity also we know, hash function is provided by each key object in the hash table. Okay, Then here it says in hash table you can store element of same type and of different type also, and in hash table key must be unique. These things we will see, and you have seen already seen few of them. Still here guys, basically I am trying to tell you, the keys, every key and store into another basket automatically. Here it generally optimize the lookup by calculating the hash code of the every key and store into another basket automatically when you accessing the value from the hash table at that time. It matches the hash code with the specified key. This is what I want to explain. That is, this time we are trying to access the value, we are trying to access what value we have stored, in play, what value we have corresponding to key 0 in our hash table, that is in my map node object. So we are saying when you accessing the value from the hash table at that time, it matches the hash code with a specified key. This line matches the hash code. How? You see, basically if I show you here, to get array position we have not inserted it as it is guys. If you remember, first we converted the key into their hash code, and corresponding to that hash code we have inserted in our hash table, right? So again we need to convert their hash code, then only you will be able to find, you will be able to fetch the value. So here we are now again converting. So 0 will have their hash code that we have, hash code is there, based on that we will again have their position, that is nothing but 2, and apps will convert it into the positive. Currently it is already positive. So now we received the position that this key 0 was inserted where, based on finding the hash code. We converted the hash code of the key, and then by finding the modulus with 3, we received key at what position 0 is stored. Okay, then we are calling get linked list at that position. So what this method does, this method is fetching the record or the linked list from that position from items array, that is currently will go at the position 2 at index 2 and find the linked list object. That is, this time this linked list variable will receive the address of 3000. Okay, 3000 is present at second index, so it will have some value. Linked list means linked list will have the address of c object, right? So definitely it is not equal to null. So this one will be linked list have address of c object, that is in our example 3000. So this 3000 will be returned, and this linked list will now be pointing to c object only. Okay, because they will also have a c object. Then what are all the key and value we have, we are putting one iteration on that. Okay, so for each linked list and in item, so what are all the element we have in this linked list, you can see we have two, right? First we have the key with value 0 and value with welcome, and at second position we have 1 and 2, and same thing you can see here also in c object. In c linked list we have two element d and e, right? So same is getting printed there also. Now in for each loop what will happen, one element at a time will copy inside this item. Okay, so first this at 0 index will be copied, that is nothing but this one 0 and welcome. So here what we are doing, we are saying item dot key dot equal. So what we are saying, item inside the item object, what is the value of key, that is 0, and we have this key also to search. So this key also is 0, both will be matched, this 0 and this 0 are equal to each other. So we will go inside that, and here guys see, even though we have different multiple values, as soon as we are getting the record, immediately we are returning, we are not putting further iteration on that. Okay, so here item dot value means corresponding to that in item we have, if I hover here, just see the value was, if you see in the link list at this item, key was 0 and value was welcome. So we are saying item dot value, that is welcome. So that welcome will be returned. Okay, it will return the welcome. So in hash 5 we have welcome, and that welcome will be printed. If you see, so here it says at 0th index we have welcome. So this is how basically you can insert the record as well as fetch the record based on the key. Quickly, let's do one more iteration. Let's do one more analyzing, and then we will stop the video as it is going to be very lengthy. Okay, so last point that I wanted to allow, कि in a hash table key must be unique, duplicate keys are not allowed. Let's do this intentionally and check whether are we allowing or not. Okay, so currently intentionally what I will write, I will say hash dot add. Okay, and we'll take any duplicate, maybe this 0. Okay, so this is the key that so I will say this comma value, we can say anything. Okay, maybe say checking duplicate keys like this. Okay, this is the value. So directly I will come here and we'll put one iteration on this also. Okay, here, and then we'll find कि when we are trying to fetch the 0 record, which value are we getting, whether the previous one or the last one. Okay, so this is checking. I will run in again and will iterate. I will trace the code to check how in duplicate case how our code will work. So again, key is 0. Okay, and value is checking duplicate one. And guys, I kept breakpoint directly here. It means already these three were added in the same manner that we had here. Okay, and then we'll check. So in this time, okay, what will happen? Okay, let's go at F11 here, get array position. So it will find out what we have. So in hash code, it will find the hash code that you see. We have something else. Actually, what happens? In different iteration, we are getting the different values. Okay, for different hash code. So this time we are getting this one. So maybe it's not possible as of now, but guys, I just want to make sure diagrammatically, because this time see, previously in previous iteration we had same index, same position for value 2 as well as welcome. But this time, because of different hash code, what happens, कि every time you execute the code, we are getting different hash code for same key. Earlier we were getting 177 something like that, if you remember. Currently for that we are getting this. If we check their position, so see, for that this time position we are getting 2. Okay, this time also we are getting. So let's check with this if we can, otherwise I will explain how it works. Okay, so it will return 2, and at that 2 we already have the value. So what happens, कि get linked list at that to at this item position 2, we already have the value, this value, right? At 2 we have the C object. So it will not be equal to null. It will return the address of linked list that they have already counted to. If you see, we have 0 and welcome, as well as we have 1 and 2. So you can see 1 and 2, this object here. Already in this linked list we have two objects, D and E. Then again, this linked list basically is holding which address? C object address, because at second index C object address is there. Okay, so it will return 3000, means this linked list is pointing to this object, C object. That is, if I draw linked list, will be pointing to this only. Okay, so that is, it will point to C object. Okay, so here this is pointing to that object. After that, one object of key value data will be created with key set to 0 and value set to this value, this string. Okay, so one object, let's create somewhere else, maybe here, key is set to 0 and value will be this only. So something like this, okay, checking retrieval, and they will have some address, maybe 7,000. We can take their name as H or something, okay, and then it will be there will be one variable. If you see item, the item will be pointing to that. So I can say item equal to 7,000, and here this item will point to H object, okay. Yep. Or something. Yeah. So item, then we are saying add last. Linked list is pointing to C object, and in that C object E is the last element. So after that H will be added. So here if I tell you ki after E in the same linked list, this one will be added, means this next now will be holding 7,000, okay. So here it will be 7,000. You can see records are getting inserted, but what is the meaning of that? We'll explain, just wait. So this one, this next actually will be pointing to this object. Sorry for getting the complex diagram, Okay, so this has happened. Now H got also inserted. So we are able to insert, right? And then all the locally variable will be destroyed. That is, this item will be removed. And then here linked list will also be removed, okay. Yep. That's it. After this, we added successfully. Now again we are saying ki we want the value present at 0. So what does mean by ki duplicate keys are not allowed? Are we something that we will get the both value welcome or this, or are we get only welcome and checking duplicate? What value exact are we getting individually, both or any one, welcome or this one? So let's trace again, okay. And here get array position, so key is 0 only. Again hash code will be finding, we know guys keep this point in your mind, key always in hash table records will be inserted based on finding the hash code first, okay. As long as you are not finding, means you are not following the hash table approaches. So here we find the hash code, then we will find the modulus of that, that is nothing but 2, and it will make positive, so position became true. We are saying get linked list as position 2. You know how it was, directly it will return the address of 3000 C object address. So I will say this time F10, and now in that it will find the value with this. So in this linked list you saw the linked list which present at 3000 address is holding three object, right? D, E and H. So these three, and that's why we are getting three element now. At 0 we are getting welcome, at 1 we are getting 2, and 2 checking duplicate keys. So let's see what value it returns. In first iteration the zeroth index will copy inside item, and in 0 if you see we have 0 and welcome, so key only will be matched. So inside item dot key we have 0, and our search key is also 0. So in first iteration only condition will be true. It will no longer check the other values, and it will just be returning the value present for the first key, first 0, right? So in that, in item we have corresponding to 0 key we have the value welcome. So this welcome will be returned, and after that return will make this condition come out of loop, and it will not execute the further iteration. That is, it came out and it is still giving a welcome. So even though you see when you are adding the record, in fact it is getting added, but still we are getting the first record only, which convince you that it is giving us the feeling like duplicates records are not getting inserted. And in hash table, in fact, also see when when we tried inserting at zero position, which is hash table, this array is actually managing the hash table. So you can see, even though we were able to add the zero record again, but where? In a linked list, not in this array. And thing is ki we should be in a position to add the array. You see, our logic is not allowing to insert the duplicate keys in this array, and this is the important with context to this